should be good enough. Okay, so I've highlighted, this is taken straight from the review document, and I've highlighted some of them that I want to be sure and cover. But before we get started, if you've run into any problems in this document or any other situation for that matter, then we want to get those problems resolved first before I go into this document. That was a question. Do you have any issues that we need to deal with?
Not yet. Not that I can think of.
Okay. So as we're going through this, stop me if you don't understand my explanation. All right. So let me take a quick look to see how this is numbered. I think it's numbered sequentially. Yeah, front to back. All right, so I got number 1, which is the number of milligrams in 6.6 kilograms. This is our starting point. And we want to change the units to milligrams. This is a dimensional analysis problem. You need a conversion factor. Remember, all conversion factors are equal to 1. So it's going to be a ratio of kilograms on the bottom, because this is numerator, that's denominator, they'll cancel. And then milligrams on the top, because that's what we want to remain. Now we need the relationship between milligrams and kilograms. So how many milligrams in a kilogram? Well, kilo means times 1,000. So there are 1,000 grams in a kilogram. But there are 1,000 milligrams in a gram. So that's 10 to the 6th. We actually have 10 to the 6th milligrams in a kilogram. And then we cancel the kilograms, and we can write this, since that's 10 to the 6th power, we can write this as scientific notation, just as is. Okay, so that makes the answer B. Number 2. Water has a density of 1 gram per milliliter. Which of these objects will float in water? All right. So what we want to do is determine the density of each one of these objects. And if the density is greater than water, it'll sink. If it's less than water, if it's less than 1, then it'll float. And we're looking for the one that'll float. Okay. So we need to determine density for each one. This is my Henry Ford procedure, assembly line. Each one is going to be calculated the same way, but with different numbers. And if we set it up right, we just change the numbers for each of the examples. Let's see, in the first one, we've got 50 grams per 69.4 milliliters. Well, let's do this. Just as a reminder, density is mass per unit volume. And density of water tells us the value that we want to say it's equal to 1 gram per milliliter. So as long as our units are grams and milliliters, we're in good shape. Yeah, and they all are. 50 divided by 69.4. 50 grams divided by 69.4 milliliters. And the second one is 60.9 grams divided by 54.7 milliliters. And the third one is 100 grams divided by 40 milliliters. All right. Now, what I'm trying to do here with the next step is to save you time. To answer the question, we don't need to know the exact number. We just need to surmise from this ratio here and here and here, is the answer going to be less than 1, greater than 1, or equal to 1? 50 divided by 69 is less than 1, correct? 60 divided by 54.7 is greater than 1. And 40 into 100 is greater than 1. So what that tells us is, this is the only one that's less than 1 gram per milliliter. So Roman numeral 1, which would be B, 1 only, will answer this question and get you out of this one and on to the next one if you're in a time constraint, like during an exam. All right. And 3, let's see. Let me just erase these before the board gets too cluttered. So the question is, convert minus 12.2 degrees C into Fahrenheit. Minus 12.2 degrees C, and we want degrees Fahrenheit. So what's the relationship? Well, the review document and the useful information that's available along with the exam. And when you get to the exam, like I mentioned last first session, I think, when you get to the exam, if you're going to take it online, be sure and print a copy of the useful information in the exam module. Because when you start the exam, Lockdown Browser is not going to let you print anything. So be sure you have a copy of that useful information, and it will have the formula or the equation for converting centigrade to Fahrenheit. So I have this one memorized. There you go. So we know what this one is. So really all we need to do, and your book may call this 1.8, same thing. And this is going to be minus 12.2 plus 32. So we need our calculator. Let's see what I did with mine. Here we go. Okay. So in here we've got minus 12.2. And I'm times 5 and divided by 9. And then plus 32. So I get 25.2 degrees Fahrenheit. And that would be, oops, hold on a second. Is that right? Let me see if, oh, I see the problem. I made a mistake. 12.2 needs to be negative. Then 5 times 9 divided plus. No, it's 25.2. Now, why is the answer 10 here? There might be a mistake in the key. Let me be sure. Won't be the first time I've made a mistake in the key. Yeah. Now let me see, did I get that right? Yeah, minus 12.2. Minus 12.2. Okay, there's a mistake in the key. That should be 25.2. There you go. Yeah. I'm gonna do it one more time, just in case. 12.2, make that a negative. Then I'm gonna use 1.8 instead. 1.8 times. Ah. No, it's not a mistake. I used the wrong formula. I should have seen the clue 1.8. 5 divided by 9 is not 1.8, it's 9/5. So that is 10 degrees Fahrenheit. All right, so let me change this back. The key was right and I was wrong. There we go. All right, now let's scroll down to 7. 232 degrees Fahrenheit is equivalent to, and all of our choices are centigrade. 32.0 degrees Fahrenheit. All right, so you have two choices. You can either go from this one and just plug in the number and solve for C, or you can solve for C before you plug in the numbers. This would be F minus 32 equals 9/5 C, and then minus 32, this would be 5/9 equals C. That way, we've already done the algebra, and we can just plug in the numbers. Oops. That's 2. There we go. Now let's see if I can get this one right. Oh, that's 200. 232 minus 32. 200 times 5/9. Okay, that's 1, 1, 1, 1 degrees C. And the answer is C. Good. Moving on. Number 9. Which of the following describes a chemical property of gold? So remember the difference between property and change. If we're describing a change, we're actually saying such and such input yields an output. If we're saying property, we're talking about potential. What is the potential for chemical property of gold? Well, we know various physical characteristics of gold, like it's dense and it has a color and any number of things. So what we're looking for is something that describes the potential of gold, either to do something or not do something. So A is gold is a very dense metal. Density is a physical property. Gold is a soft metal. That's also a physical property. Gold is an inert, non-reactive metal. Okay, that's the key. It's not saying that it will react with something, it's saying it won't react. And that is a chemical property. D, gold is yellow. E, gold is a good conductor of heat and electricity. Those are all physical properties. The only one that's a chemical property is C. Gold is an inert, non-reactive metal. All right. we're getting into some significant figures here, it looks like. Yeah. So, 12 says we want to know the sum of 54.34 plus 45.66. So remember that you've got two rules to deal with. You got the add subtract rules and the multiply divide rules. This is a subtract, this is an add rule, 54.34. Okay, and 45.66. And what we do is line up the decimals. And then we just add them together. Use your calculator or you can do it in your head. Here, 1, there's another 0. Carry the 1, there's another 0. And 10. There we go. So that adds up to 100.00. And because these are both at the same position, then we don't have to round. We can keep everything. So the answer is 100.00. And the question is, how many significant figures are in the answer? And in fact, there are 5 significant figures in that answer. It has zeros, but there's a decimal. Zeros to the right of the non-zero number, and there are decimals. There's an explicit decimal there, which means that all the zeros count. That means our answer is 5D. Okay. Uh, 15, which of the following is an element? All right, I'm not going to put this one on the board. You just have to recognize what's an element, what's a compound, and what's a mixture. Right? Alcohol is a compound. Salt, and I assume they mean table salt. Table salt is a compound of sodium and chlorine. Helium is an element. If it's not found on the periodic table, then it's not an element, right? Alcohol, salt, sugar, and vinegar, none of those are on the periodic table, only helium. So this is where you have to recognize elements based upon memorizing the symbols. I gave you that first task was to memorize the symbols. And you can, you will have a, let's see. Let me be sure. Ooh, nope. There's no periodic table with this one. So you just have to recognize it. Know the difference between an element and a compound or a mixture. $18. All right, how many liters are in a 29-ounce bottle of pop? So we're starting off with 29-ounce bottle. And we were given conversion factors there in the problem. We want to end up with number of liters. Remember, and liters, the abbreviation for liters is a capital L, not a small l, capital L. So if we're going to go from ounces to liters, we're changing systems. We need a way to change into, well, let's see what conversion factors we're given. 1 quart, 32 ounces, and then 1 liter is 1.0567 quarts. So the first conversion we're going to make is into quarts. Right? I've seen some of my students in the past learn how to do these calculations rather than parentheses. They just drew a line and they had something here, and then they had something here, and then they had something here. You can do it that way rather than parentheses. I use parentheses just out of habit, I guess. But we got to have ounces down here to cancel the ounces in the numerator. And then we also have quarts up there. So the ratio here is 32 ounces per quart. All right. And now that we've gotten rid of ounces, we can convert quarts to liters. Right? 1 liter is 1.0567. 1.0567 quarts is 1 liter. Okay. So this is the thinking part. The rest of it is number crunching. So if I take 29 and divide by 32 and divide by 1.0567, I get, let's see, the answers are in standard notation. All right, so these are exact numbers. They don't influence the multiply rule for significant figures. This has two significant figures. The answer can have two. All right, so my calculator, let's do it complete. My calculator tells me 0.856228 liters. If we can only keep two of those significant figures, that means this is not significant. 1, 2. So we're looking at this one, and that means this one's greater than 5. So that means this one is promoted 6 liters. There's your answer. And that would be B in this case. Okay. Next one, 20. Which of the following is a homogeneous mixture? The way the English language is set up is the modifiers come before the noun. The mixture is the central object here, mixture. So first thing we want to do is find out which one of these is mixtures. If it's not a mixture, then we don't even have to consider it. Then we look at the mixture and say, is it homogeneous or heterogeneous? In this case, gasoline is a mixture. Yep. Copper metal's not. Jelly beans, that's a mixture. Pure water is not. Soil is a mixture. So we've got those three: gasoline, jelly beans, and soil. Which one's homogeneous? Well, I think I mentioned in class that soil is heterogeneous. You can take my word for that. Jar of jelly beans, you can observe that for yourself, and you can see differences in composition wherever you look, difference in numbers of different colored jelly beans. The only homogeneous mixture, or another name for that, is solution. The only solution in there is gasoline. Right, so that's A. And let's scroll down to 22. Go. 22. A graduated cylinder contains 20 milliliters of water. All right. This is one of those cases where I think a picture would help. We've got a graduated cylinder. And it contains 20 milliliters of water. So let's say this is a 50 milliliter graduated cylinder. That means 20 is going to be about right here. All right, so we got 20 milliliters of water right there. An irregularly shaped object is placed in the cylinder and the water level rises to 31.2. So it rises up to about right here. With this irregularly shaped object in the bottom. Okay. If the object has a mass of 80.4 grams, now this object has 80.4 grams is its mass. The question is, what is its density? Remember the formula for density, of course. Mass divided by volume. So this is the volume of the object, not the volume of the readings. What is the volume of the object? The volume of the object is the difference between these two. 31.2 minus 20.0. So that's 211. 11.2, oops, not grams, milliliters. So this is 80.4 grams and 11.2 milliliters. 8.4 2. So I get 3 significant figures. This is a divide rule. 71 point. Well, let's be consistent. 71.7857. We can only keep 3 of them, right? So we're dividing line here. That's greater than 5 grams per mil. And remember, when you do a calculation, don't forget the units of measure. The units of measure here are grams per milliliter. We divide these two together and get that value, but grams per milliliter must remain. Nothing cancels. It has to stay there. All right, 71.8 would be, oops, I made a mistake. Yep, sure did. Not 71.8, it's 7.17857. So we're going to have 3. That means this is 7.183. There we go. All right. Number 25. What Kelvin temperature reading equals 61.2 degrees Fahrenheit? 61.2 degrees Fahrenheit. All right. We don't have a direct conversion from Fahrenheit to Kelvin. We could probably, I mean, if you're good at algebra, you could probably invent one. But otherwise, convert Fahrenheit to Celsius. And then convert Celsius my mind's gone blank. $73. 73. Okay, so if we plug this one in here, 61.2 equals 9/5 C plus 32. Then 9/5 C equals 61.2 minus 32. And then this would be 5 divided by 9. So 61.2 and 32 minus divided 5 times. So that's 16.2222. These are exact numbers or counting numbers. So we have 3 significant figures. 16.2 is degrees C. Okay, would be 16.2 plus 273. Actually, we can tack on, I'm not sure if it'll make a big difference. 273.15. Is 289.35. We line these up, we can only keep 1 decimal, so this is 4. 4. Okay. 289.4 is C. Okay. Now, if we were trying to invent or derive a formula that would go straight to Kelvin from Fahrenheit, what we need is to solve this one for C, and then substitute that in here. Right? So that would work. But if you're not comfortable, if you haven't had algebra, you're not comfortable with this, then do it the 2-step procedure. right? 26. Which of the following processes is a chemical change? All right. We need a description of a change in identity of a substance. So let's just take them one at a time. Dry ice sublimes when left on the demo table in lecture. It's just changing phase, right? It's still carbon dioxide, whether it's solid or gas, right? So A can't be it. Let's see. The light on a candle burns until a bell jar is placed over it for a period of time. Yeah. What are we doing? We're starving the flame for oxygen. So when it uses up all its oxygen, it goes out. That's a description of a chemical change. And then if you look at the others, when a few drops of red food color are added to a beaker of hot water, the water becomes red. That's simply a solution. It's a mixture. It has no, as far as we're concerned, there's no chemical change there. Liquid nitrogen dumped onto the floor vaporizes. That's kind of like dry ice. It's just changing phase. And none of the above. We did find one that was a chemical change. B, the light on a candle burns until a bell jar is placed over it. All right, so 26 would be B. All right. Now this one, 30. Test your knowledge of prefixes, the Greek prefixes that modify units of measure. So which one represents 1/10? Well, if we do MKCM, MKCM, and D, what do each one of these mean? This is mega, this is kilo, this is centi, this is milli, and this is deci, right? Mega in front of the unit means multiply times a million, 10 to the 6th times. Kilo is 10 to the 3rd times. Centi is a tenth of 1/10 times. Excuse me, 1/100th times. Milli is 1,000th of. And deci is a tenth. There's your answer, deci. E is the answer. All right. 36. See how we're doing on time. Okay. The volume in milliliters occupied by 41.9 grams of mercury. All right, so what are we given? Well, actually, let's find out what the question is first. The volume is, we're looking for the volume of this mercury, right? So we're looking for that. Well, how are we going to get there? Well, we're given density and it's got volume in it. So we need the density relationship. Right? Or solve for volume. Then let's see if we've got values for mass and density. Density 13.6 grams per milliliter. And mass is 41.9 grams. Right, notice when you put a quotient in the denominator, it's like writing the milliliters on top and the grams stay in the bottom. Right? So this is in the denominator, those cancel, and this in the denominator of the denominator is the numerator. So our units of measure will be milliliters. It's just rotates up. All right, so 41.9 divided by 13.6 is 3.08088. So 3 significant figures in each one. That means 3.08 milliliters. And that's A. All right. More significant figures. 40. How many significant figures are in this number? 40090. All right. Yep. Well, we know that these are not significant. These are bracketed by non-zero numbers, so they're significant. And this one is significant because there's a decimal right there. So 1, 2, 3, 4, 5. 5 significant figures. Okay, answer is E. Let's see, 41, the SI prefix that corresponds to a factor of 10 to the minus 2. I had that one on the board a little bit ago. 10 to the minus 2 is 100th. 100th is centi, like centimeter. That unit, the centimeter, is 100th of a meter, right? So you take a meter, chop it into 100 pieces, that's a centimeter. Let's see what we got here. How many significant figures? So we're given this calculation. Yes, okay. So we have, let me write it up here. 7. 0.433. Let's see. They're all in line. There's no division in there. Okay. 0.4333 joules per gram. And then we've got 33.12 minus 31.12 degrees C. And then times 412.1 grams. All right. So our order of operation, remember, do everything inside the parentheses. Well, that's a single number. That's a single number. We just need to figure out what this one is. 33.12 minus 31.12. Okay. 0, 0, 2. So this is 2 degrees C right there. That was the add subtract rule. Now we've got multiply rule. 2.00. And all it wants to know is how many significant figures. So now, once we've got this in here, we're taking that 3 significant figures, 4 significant figures, 4. We're limited to 3 significant figures. That's why the answer is B. You don't even have to calculate it out. Because the question, based on the rule, the question is answered by 3 significant figures. All right, scroll some more. 48. Which is an example of another homogeneous mixture? All right. Well, let's see which ones are mixtures. Soil, that's a mixture. Sodium chloride is a compound. That's a pure substance, so it doesn't count. Aluminum is an element. It's a pure substance. Vodka is a mixture. Oily water is a mixture, yes, but it's heterogeneous. And soil, vodka. Excuse me, I missed that one. Soil is heterogeneous, and vodka is a mixture of primarily water and ethanol with some other minor components. So that would be a homogeneous mixture. It is a solution. That's D. 48. They skip quite a few. There's a lot of repetition in here, which is why I mentioned early on, your 2 best friends in chemistry are curiosity and the other is boredom. So if you work all these problems and you get bored working some of them, then you know them well enough. That's basically why I'm skipping them. Okay. Let's see what we got here. 68. A cubic centimeter is equivalent to what other metric volume unit? Oh, this is a test of your memory. That is equal to 1 milliliter. So the answer is E. 71. The state of matter for an object that has a definite volume. Definite volume. And what else? But not a definite shape. That is a liquid. Or sometimes we put it like this. Like that. That's a liquid. Right? So E is the answer. Let's see. Skip. Here we go. Let's see. Let's look at this one. 84 refers to that beaker on the right. And the beaker's got something in it. You take 20 milliliters of water from a graduated cylinder and add it to the beaker of water below. What's the new volume of water in the beaker? All right. So that beaker is marked off in 10 milliliter increments. All right. 10, 20, 30, 40, 50. And we're at a level of right here. Okay. Now we're going to add 20 milliliters of water. 20.0 milliliters of water. Go in here. So where's it going to go? Right? We add 20 to 15. 15 plus 20 is 35, right? So it's going to be right up here. But how can we report that? Which one is the least accurate? Well, we're saying that the graduated cylinder measures out to a tenth, but this one only measures to, we can estimate 1. We can estimate 15 here. That means our estimate here can only be 35, not 35.0. That's the trick. It's 35 because this is the least accurate of the two. That limits our claims on both on the certain and the uncertain digits. All right. '94. Which of the following is only a physical change? All right. A, leaves turn color in the fall. Well, the color speaks to a physical property, but the process that gives you the colors is chemical, right? So that's why the key word there is only a physical change. A banana ripens. No, that's a biochemical change. C, cookies burn in the oven. we're taking the flour and the sugar and whatever else and ashing it, turning it to carbon. That's when we burn it. Right? So that's a chemical change. Sugar dissolves in coffee. That's purely physical. The sugar is introduced to the coffee and becomes a sugared solution. That's a physical change only. And E is one of those wonky ones where it says at least 2 of the above exhibit only physical change. No, 2 of the above, at least 2 of the above do represent a physical change, but not only a physical change. The one that exhibits only a physical change is D. Got a lot of repetition in there. 107. A blank is a summary of observed behavior, and a blank is an explanation of behavior. This is early on in our discussion. The difference between a law and a theory. The law explains what? Just what happens. The theory explains why. All right, so a summary of observed behaviors is what? That's the law. An explanation of the behavior is why, a theory. So we have a law and a theory together, that's B. $114. Your friend is 5 foot 9.8 inches tall. 5 feet 9.8 inches tall. What's your friend's height in meters? All right, so we've got an addition problem here first. What we have to do is say, okay, what conversion factors do we know, or what conversion factors are given to us in useful information? All right, there's an inch to a centimeter, right? That goes from the English system to the metric system. There's a meter in yards. So the centimeters is probably our best bet. All right, so first thing we have to do is say, all right, if our conversion factor is 1 inch per, well, let's see, let's do it this way. 2.54 centimeters per inch. Then we need to convert this to inches. Right, so 5 times 12 is what? 60 plus 9.8. This would be a counting number. Right, so we can keep all of our decimal places out to 69.8 inches. So now that we have inches, we can put inches on the bottom and centimeters on the top. That will give us centimeters, but it won't give us meters. But now we are in the metric system. So now we can convert centimeters to meters. So how many centimeters in a meter? Well, one way to look at this is, what does the prefix mean? The prefix means 10 to the minus 2 meters. So this unit of measure is 10 to the minus 2 meters. Or you can say 1 meter is 100 centimeters, right? 10 squared. 10 squared in the denominator is the same thing as 10 to the minus 2 in the numerator. So either way works. Okay, we got rid of centimeters, now we got meters. So all we have to do is calculate. Let's see, 69.8 and 2.54. And I get, let's see, 3 significant figures. I'm going to round this one off before I put it on the board. 177 times 10 to the minus 2. Right? So 10 to the minus 2 means 1, 2. Move it over here. 77 meters. Okay, so the answer should be, well, all right, this brings up another point. In a multiple choice question, if none of the answers are exactly what you get in your calculation, yeah. If none of the answers are exactly what you get from your calculation, and there are none in there that say none of the above, one of the above, two of the above, those oddballs. If they're just simple statement of values, then you pick the best one. And the closest one to 1.77 is 1.8. So that's why E is the answer for this one. All right, 116. Which of the following is an incorrect description? All right. Which one of these are examples of terms that don't go together? That's what we mean. A homogeneous mixture. Is that valid? Yeah. A homogeneous mixture is a solution, so A is good. B, a solid element. Sure. Most of the metals are solids. And then a few of the nonmetals are solids. A solution of gases. Yeah. In fact, I'm breathing a solution of gas right now. Nitrogen and oxygen and some argon and some minor components. Gases mixed together always form a solution every time, a homogeneous mixture. How about D, a mixture of solids? Yeah, it's possible. Think alloy, right? Nickel and copper together makes brass. That's a mixture of solids. Or E, heterogeneous compound. Is that possible? The answer is no. A compound is a pure substance. So we can't use terminology for a mixture when we're discussing a pure substance. Right? So E is the one in that of all those terms that doesn't belong there. 119. Okay. So let me move this out of my way so I can see what we're looking at here. Okay. This device, right, it's got a stopcock at the bottom and then a delivery tube. And then above the stopcock is a calibrated cylinder. And notice that it's numbering from top to bottom. So 10 would be up here and keep going. 10 there's and 0 there. 0 down 2. This is called a burette. And a burette is designed to measure out volumes. In other words, if you start at 0 and you end up here at 22 milliliters, then you have delivered 22 milliliters through the device. But is it 22 or is it 22.0? Well, notice there are markings on here for every milliliter, right? 21, 2, 3, 4, 5, 6, 7, 8, 9, 30. That means the certain numbers are 2, 2 because there is a line for it there on the device. It's calibrated that way. The next one is a guess. So now we go out and guess. Looks to me like it's right on the line, so I'm going to guess 0.0. Right? That's why the answer is D and not E. Oh. 124. Aluminum has a density of 2.70 grams per cubic centimeter. Let's just put that up here. 2.70, yeah. 2.70 grams per cubic centimeter. And the reason it's cubic centimeters is because this is a solid. Solids are in cubic centimeters, liquids are in milliliters, just by convention. What's the mass of a rectangular block of aluminum measuring 11 centimeters by 22 centimeters by 34.5 centimeters? All right. We got the density. The density is equal to mass per unit volume. The question is, what's the mass? Right? Yeah, what's the mass? Can we calculate volume from those values? Yeah, if it's a rectangular block. There you go. There's your rectangular block. It says it's measures 11.1 by 22. So let's call this one 11.1 centimeters. And this one's 22 centimeters, and the length is 34.5. So we know that the volume of that block is height by depth by length. That means multiply these together and you get the volume. All right? So let's multiply those together. 34.5 times 22 times 11.1. Correct? Just checking myself. 22.2. Let's start over again. 34.5, 22.2. There we go. 11.1 times. Okay. So we got three significant figures here. We can keep three in the answer. So the volume here equals, let's see, 850,149. Okay. Cubic centimeters. Now, we're supposed to only have three significant figures here, but if we do that, we may introduce a rounding error. So since we're all multiply, divide, and there's no add, subtract in this problem, we'll plug this one in here, which means the mass equals density times volume. That's 2.70 grams per cubic centimeter times 8501.49 cubic centimeters. What are our answers? Notice our answers are in kilograms. This is going to give us our answer in grams. So we'll find that first, and then we'll convert to kilograms. Okay. We can only keep three significant figures out of this calculation. So if I say this number times 2.7 is 2.2954 times 10 to the fourth grams, because cubic centimeters cancels. So, how many grams in a kilogram? 1,000, right? So we take 10 to the third out. We factor out the 10 to the third here, grams. And that means this is kilo. So now we have 2.2954 times 10 to the first kilograms. That's 22.954 kilograms. Now that we've done all our calculations and then only multiply, divide, and we can reduce this to three positions. 23.0, right? Kilograms. Now, is that one of our answers? Yeah, A, 23.0 kilograms. Right. Let's scroll a little bit, see how we're doing. Okay, I think we're doing pretty good on time. Get these, let's take these two together. 132. Another unit conversion. Yeah. Convert minus 47.9 degrees C into Fahrenheit. So let's see if I can get it right this time. Fahrenheit equals 9/5 C plus 32. Minus 47.9. All right. Yeah, 47.9. Change that sign. 9 times 5 by 30 plus. Okay, so my calculator tells me minus 5.422 times 10 to the first power. All right, this multiplication gives me three significant figures, and these values here are exact numbers, so I'm only concerned with that one. Three significant figures. Let's see, this would be minus 54.22. Right, if we put this one in here, moves the decimal to the right, then I can keep three of these. So minus 54.2 degrees Fahrenheit. That's why E is the answer here. Okay. Let's scroll on up. 133. Which of the following involves no chemical change? All right. Baking a cake. When you bake a cake, what does it do? Well, it starts off as batter, at the bottom of the pan, but it rises, right? It's making gas. Where did that gas come from? It came from a chemical reaction. Right? It came from the sodium bicarbonate that we put in there, along with a little bit of, well, if we use baking powder, it's already got the leavening agent, sodium bicarbonate, plus it has an acid. Whenever you react an acid with sodium bicarbonate, you get carbon dioxide gas. So this baking of a cake is chemical reaction. Boiling water. No, that's physical, right? You're just changing states there, right? So notice we don't have any of those two of the above, none of the above, those types of statements in there. So when you're working a problem like that, if you know that you've got the answer, you've gone down from A to B, B is the answer. You can stop. Or you can look at all of them. Lighting a match, burning paper, driving a car, all of those involve chemical changes. Boiling water does not. So 133 is B. 134. Copper has a density of 8.96 grams per cubic centimeter. If a cylinder of copper weighs 34.94 grams is dropped into a graduated cylinder containing 20 milliliters, what will be the new water level? Right? Let's draw a picture. Okay. Let's say we have, I don't know, let's say this is a 50. So 20 would be down here somewhere. Okay. Now we're going to drop that copper cylinder in here. Right. Our copper cylinder. We want to know what's this volume right here. So what we need to know is what's the difference there? And we can figure that based upon the density of copper and its mass. Density equals mass or volume. We want to know the volume of the copper cylinder so we can add it to 20 milliliters. So what was the mass of that cylinder? 34.94 grams. The density is 8.96. Okay. So if we divide those out, the grams cancel, leave us with cubic centimeters, but a cubic centimeter is a milliliter. So let's see, 34.94 and 8.96 divide is 3.89954 milliliters. Right? Yep. Okay. We can only have three of these. We can only keep three of those. And the reason we have to round it now is because the next operation is an add subtract. Right. So we have to round it now rather than later. So if we're going to three significant figures right here, that's greater than 5. So this one rounds up, makes it 0. Add that to this one, 3.9 milliliters. Now, we've got, do we have 20? Yeah, 20.00. Okay, so 20.00 milliliters, and we're going to add 3.90 milliliters, 0.932. 23.90 milliliters. That's why D is the answer. All right, 137. How many significant figures are in the number 4.00700? 4.00700 times 10 to the 13th. The authors of this question are trying to trick you. If you have a number in scientific notation, the significant figures are carried in the coefficient right here. That's 1, 2, 3, 4, 5, 6. 6 significant figures. Okay. Which of the following is not a step in the scientific method? One 38. You usually start off with an observation. Then you propose a hypothesis, an explanation for the observation. You can put it in the form of why it happens or just describing how it happens. Either way, that's a hypothesis. Then you experiment and compare the answers of your experiment to the hypothesis. So let's see, which one is not a step? Change results to agree with your hypothesis. Okay. If you do that and you try to publish your work and somebody finds out about it, your career is over. If you try to fudge the data, that will be a career ender for you in the sciences. All right, so we found the wrong one. That's A. You never change the results to agree with your hypothesis. You compare the results with your hypothesis to see if the hypothesis is true. All right. See, we can get 3 on there, 148. An example of a mixture. All right. So if we find any pure substances in there, we can ignore those. Gold is an element, that's pure substance. The air in the room, yes. Correct. We're good to go. And B, air in the room is a homogeneous mixture. That's the answer. Purified water is a compound. It's a pure substance. Hydrogen fluoride is a pure substance. All right, so the only mixture in there is B. $149. That was starting to get weak on me. Let me pull out another. Here we go. Get a marker that works. Okay, how many of the following are compounds? Remember what a compound is. Two or more elements. To create a new substance. So let's see. Water has two elements in there. N2O4 has two elements. NaOH has three elements. MnO2 has two elements, and HF has two elements. They're all compounds. So it's 1, 2, 3, 4, 5. A is the answer. Okay. How about 150? How many of the following are pure compounds? Well, sodium is an element. It's not a compound. Sugar is a compound of carbon, hydrogen, and oxygen. That's true. So sugar is there. Oxygen is an element. Air is a mixture. Iron is an element. Those are pure substances, not pure compounds. Sugar is the only pure compound in there. So that B is the answer because there's only one. Okay, let's scroll down to the next one. 154 and 56. We get both on there. 154. Helium is an example of, we had a question like this before. Helium is an element. Yeah. It's not a mixture and it's not a compound. So A is the answer to that one. Helium's an element. How about 156? Which of the following is an element? Right? Water's a compound. Earth is a mixture. Salt is a compound, and I assume they mean table salt. Brass is a mixture. Oxygen is an element. And it looks like this. Let's see, 156. It has two oxygen atoms bound together. But they're not two different atoms, so this is an element. It's what we call a diatomic element. And you'll notice in that, let me get a copy of it. In this periodic table where I wanted you to memorize the symbols, I've got some of them in blue. Hydrogen here, then we've got nitrogen, oxygen, fluorine, chlorine, bromine, iodine. Those in blue exist at 1 atmosphere pressure and room temperature. They exist as diatomic elements. So oxygen's in there, nitrogen's in there, fluorine, chlorine, bromine, and iodine. The reason you need to know that is if you're given a problem in the future to write the reaction for something like this, and one of those reactants is one of these, you don't write it as a single element. I mean, oxygen is O, but it occurs as O2. So if I said hydrogen and oxygen combine to make water, right? Hydrogen, oxygen yield water. We're going to learn how to balance those equations. But if you write it that way, it will never balance. It needs to be 2 here, 2 there. Then we can balance it. Right? We say put a 2 here and a 2 here. So those diatomic elements, you need to memorize. Oh, that's a stubborn marker. All right. Scroll 161. What's the result of the following multiplication expressed in scientific notation to the correct number of significant figures? So in this case, you do have to complete the calculation. 5.46 times 10 to the third. Times 8.0 times 10 to the minus third. 8.0? Yeah. Now you can plug those into your calculator and you get an answer, and the answer can only have two significant figures. Or you can say 10 to the third times 10 to the minus third is 1. So now you can say 8 times 5.46. And I get 43.68. But we can only keep two of these. So that means we have to round it here. 44. So the answer is, oh, it's in scientific notation. So that's equal to 4.4 times 10 to the first power. Right, that's C. All right, 169. A blank change involves a change in the fundamental components of the substance. A given substance changes into a different substance or substances. So is that a the only two possibilities that we've studied so far, it's either a chemical change or a physical change. Okay. So if it changes into a new substance, it's chemical change. The identity has changed. That's chemical. Oh, that's it. That's all the ones I had marked. If there are any others that you think of, we can go over them. Otherwise, the test will be due by 11:55 on Thursday, this coming Thursday, the 25th of January. So like I said before, if I get somebody face-to-face in class that wants to take the paper exam, then I'll wait until they're finished and I've graded it. And then we'll go into the next topic, which is Chemical Foundations, Chapter 4. If nobody shows up, then I'll just go in and do the lecture on Chapter 4. Otherwise, I'm going to stop the share and we're finished. Unless you have questions.
Yeah, did you say we're allowed to use that like little useful information paper on the exam?
Yes.
Okay.
Yeah. When you go into the exam module, then there'll be the link to the exam, plus below it, there'll be something called useful information. That's a PDF document. Just download it and print it so you'll have it for the test.
Okay, thank you.
Okay. We'll see you later.